least common multiple. Least common multiple is a number that can be pulled out of a set of numbers. So let's talk about first example here. What I would do is just write it down. And you don't have to do it this way. This just seems to make sense. You can make a tree diagram, a box diagram, whatever works for you. So what I'm going to do is I'm going to write this down. I know that 20 is 2 times 10, which can also be written as 2 times 5. I know that 45 is what? 5 times 9, which 9 is 3 times 3. To find the least common multiple, what I need to do is pick out the base once. So I see I have a base of 2, I have a base of 5, and I have a base of 3. Now let's write these in exponential form. There's 2 of these 2, so that's 2 squared, right? Because to the first power, whenever you multiply like bases, you add the powers, times that 5 to the first. Then I got 5 to the first, and I got 2 of these 3, so that's 3 squared. So what I'm going to do is I'm going to go through here and pick the one with the largest power. It just so happens to work out that 2 squared, 5 to the first, and then 3 squared. Oops, squared. I wrote a 3. All right, so 2 squared is 4 times 5 to the first times 3 squared, which is 9. So now I have 4 times 5, we know is 20. And then 20 times 9 gives me 180. So the least common multiple, which means is the smallest number that both 20 and 45 will go into, is 180. They don't go into it the same amount of times, but they both will go into it. So let's do B. B says we have 8 and 28. We know 8 is 2 times 4, which is 2 times 2. This can be written out as 2 cubed. 28 is 7 times 4, which is 2 times 2. Can be written as 7 times 2 squared. So when I go through here, I'm going to have to figure out what is the base. Well, we know we have a base of 2 and 7. And we're going to pick the one with the highest power. So the 2 cubed is going to be the one we picked. And of course, we only have one set of 7, so we're just going to take that. So that means we got 8 times 7. So the least common multiple that both those numbers will go into will be 56. I'm going to let you do C, D, and E. Let's talk about F right quick. F says we have 24. Well, I know that 24 is going to be 2 times 12, right? Well, I know that 12 is 2 times 6. Well, I know 6 is 2 times 3. So if you want to double check just to make sure your math is right, we have 3 sets of 2, so it's 2 cubed times that 3. Well, 2 cubed is actually 8. 8 times 3 is 24, so we did it right. So knowing all that, I'm just going to write 8 is 2 cubed. We know that 6 is 2 to the times 2 to the first times 3 to the first. And 20 is going to be 2 times 10, which is 2 times 2 times 5. That can be written as 2 squared times 5 to the first. Now, when I pick my bases, I got a 2, I got a 3, and I got a 5. And I'm going to pick the highest power, which is 2 cubed. 3 to the first is all I have, and 5 to the first. So now I got 8 times 3 times 5, right? So 8 times 3 is 24, times that 5 gives me 120. That is the smallest number that all 4 of those numbers will go into. All right. So let's do example 2. It says 4 tour buses depart the terminal on the same day. The itinerary of the first bus takes 4 days. The second bus takes 10 days. For the third buses, it takes 12 days. The fourth buses take 20 days. We're going to assume that another tour begins the same day that the bus returns to the terminal. How many days will it take until all 4 buses return to the terminal on the same day? That's a pretty good question. So that would be a good critical thinking one. And I really want to talk about this one in class. So think about it. Let's come back to class and talk about it, okay? To find the equivalent fractions, let's do this. So what we're doing is we have 3/4 equals to this unknown over 28. So what we need to do is figure out what did I multiply 4 to get 28? And that's how I'm going to find the numerator. Well, 4 times 7, right? So that means that's 7 times 3. So my answer here is 21. All right, so 9 times what gave me 45? It was 5. So 5 times 10 is 50. And so on. Okay, so I'm going to let y'all do these.